students. In the last class, we discussed about the topic that we started the chapter dual nature of radiation and matter. In that, we started the topic with the electron emission and also we studied about the work function. So, electron emission is nothing but if we have a metal surface, in this metal surface we have a free electrons. So those free electrons are not able to come outside by its own. So for that, the reason because of that is due to the attractive force between the positive ions and the negative charges, that is the force of attraction between the charges, and also due to the potential energy. So if the electrons wants to come out of this metal surface, then that electron needs the energy to overcome the attractive force. So that one we call as the work function, right? So that is denoted by pi naught and it is measured in electron volts. So work function is more in platinum and less in cesium, right? So after the work function, we have the physical process of emission of the electrons, that is by thermionic emission. We have the three processes. One is thermionic emission, and second one is field emission, and third one is photoelectric emission. So in this chapter, we are mainly concentrating about the topic that is photoelectric emission. So in that photoelectric emission, the process is called as photoelectric effect. So when a photo is nothing but light, when a light of suitable frequency which falls onto the metal surface, the electrons will absorb that energy and it overcomes the attractive force between the charges and it comes outside. So that process we call as the photoelectric effect. So in the earlier stage, the scientist Heinrich Hertz was first discovered the photoelectric effect. So that observation we call as Hertz observation. So in this photoelectric effects, we start with the first topic, that is Hertz observation. So Heinrich Hertz observed the photoelectric emission during the experiment of electromagnetic wave. Right, during he conducting the experiment, so that experiment is the electromagnetic wave experiment. During doing this experiment, he observed the photoelectric emission, that is the Hertz observation on photoelectric emission. The first scientist to observe the photoelectric effect is Heinrich Hertz in the year 1887, right? While doing the experiment, so which experiment it is? That is the electromagnetic wave experiment. So experimental setup, if we observe here, he considered the two metal plates, right? So this one is the metal plate and he placed another metal plates. So he kept one is at the top and here another one at the bottom. These two plates, so these are the metal plates, right? So this one is the metal plate 1 and here is the metal plate 2. So from these two metal plates, he placed one spherical metallic ball with this plate first, and also he placed another metallic ball with the plate 2. So small gap is placed between these two metal spheres. So we call this one as metal sphere S1 and this one as metal sphere S2. Right? So first he considered the two plates. Then from these two plates he connected to the two spherical metal balls. That one we call as S1 and here it is S2. So this one is the experimental setup. Next, later he connected these two plates to an induction coil, right? So these two plates are connected to an induction coil. So this one we call as, this one is the induction coil, right? So this is applied by the connected to external source, that is battery, right? So what happens here, when the source here, when we apply the potential difference to the induction coil, here the magnetic flux and electric flux which are produced, that is flux are produced at a rate of, that is pi is equals to L into di by dt for the small flow of the current with respect to small time. For very small time we get the maximum flux. So flux is nothing but it is the flow of charges, and here the charges will be stored positive, and if so this is the positive charge, nothing but here it will store positive, and here the negative charge is stored on the plate, right? So these are the negative charges which is stored on the plate when it is connected to the, these two metal plates are connected to the induction coil. Then these two plates acts as a capacitor. So capacitor is a device which stores the electric charges when it connected to the external source through the induction coil. So by the induction coil we get the fluxes, and the fluxes causes the production of the charges when these charges are stored on the metal plate, right? So when excess, if we further supply the current through this induction coil, then further the charges will store on these plates. After the excess flow of charges, then it passes through the sphere, right? So on the surface of the sphere, here we have the negative charges and here we have the positive charges. So there will be a small gap between S1 and S2, that is the air gap. So that one, the dielectric, we considered air medium as a dielectric, then value of dielectric is 1 for the air medium. If we further supply the charge, that is flow of charges to these plates, then what happens, the excess of charges due to here the charges are accumulated due to the force of attraction, the negative charges are tends to attract with the positive. There will be a positive and negative charges on these two spheres. There will be a spark produced on these two spheres. That will be the lightning will be observed in between these two spheres. That is, we observe the spark. That is spark discharge between these two spheres. So these red lines represents the spark. That is spark discharge or sparking is observed between these two spheres due to the negative electrons and positive charges are attracts in between. Air medium is there and it breaks the air medium and it goes on to the sphere of S1 from S2. Then we observe the spark discharge. So Hertz observed that he placed one more. So here the potential difference is of the order between these two plates is of the order of 10 to the power of volt per meter. Then Hertz placed one more detector loop. That is, for this here is I will write in the enlarged. Here we have one sphere and here we connected ammeter and to the, so this one behaves as S1 and S2. So this loop is the detector loop, right? So he placed one detector loop near to that of this electromagnetic, that is wave experimental setup. So here the spark will be discharged, and from this spark the radiations will flows like this, that is UV radiations. So when the radiations which are coming out from this spark, and we have one more detector loop here, we have the two spheres S1 and S2, and in the spheres, so sphere is nothing but also the metal surfaces, that near the metal surfaces it absorbs these radiation and it gets charged. That is, here it will get the negative, and here it will get the positive, right? So here also in this loop also the electrons are observed. The electrons in this sphere observe the radiations and it gains energy. Then it starts to escape from this metal surface. Then it moves in all the directions and we observe the spark in this loop also. So spark will be observed in the detector loop also. So if we increase the intensity here, then here also we get the sparking intensity is more. So from this, the hertz conducted the emission of the photo electrons by the spark discharge, right? So Heinrich Hertz, first scientist to find or to detect the photoelectric emission. When a radiation from the spark discharge falls onto the metal surface in the detector loop, then it gains the energy. The electrons which are present in this metal surface gains the energy, then it shifts. Then we will observe the spark, right? So by this, Heinrich Hertz says that the emission of the photoelectric emission, that is, electrons will move when the incident light falls onto the metal surface. So this is the experimental setup conducted by the Heinrich Hertz. So this one is the first scientist to detect the photoelectric emission, right? So we move on to the next one. So this is about the Heinrich Hertz observation. So next is Hallwards and Lensons Observation. So second, after Heinrich Hertz, Hallwards and Lensons observed the photoelectric emission, that is photoelectric effect. So in this, first we discuss about the Lensons observation, right? So in Lensons observation, that is the experimental setup, he conducted the experiment, that is he considered one evacuated glass tube. So he considered one evacuated glass tube and placed, so this one is the evacuated glass tube, that is there will be no air in present of this glass tube. Later he placed two metals. So this one is one metal and here he placed the another metal. So the first metal, we called this metal as emitter plate and the second metal he called that one as collector plate, right? So first he taken one evacuated glass tube. So in the glass tube he placed two metal plates. So first metal plate he called that one as the emitter plate and the second metal plate he called that one as the collector plate. So next these metal plates are connected to the external circuit along with the ammeter. So ammeter is the instrument used to detect the flow of current, right? So this one is the ammeter. So this one is the battery. So it is negative terminal and here it is positive terminal, right? So next, what he did means the UV rays. So if we consider this one as sun, so from the sun we are getting the UV rays. So he made this emitter plate, that is the UV radiations which has to falls on this emitter plate. So that is the radiation from the sun made to incident on this emitter plate. So these are the ultraviolet radiations, or we can say that as UV light. UV represents ultraviolet radiations. So when the sunlight, that is the ultraviolet radiation, makes to falls on this emitter plate, then what happens here means the electrons in this plate acquires the energy from this sunlight and the electrons are emitted, right? So the electrons are emitted and these electrons are attracted by the collector plate, right? So when a violet light, so ultraviolet light, that is UV light which falls onto the emitter plate, then this is the metal plate. Then the electrons which are present in this metal plate absorb this sunlight, that is sunlight is nothing but light, that is photo. Then the electrons gains the energy from this sunlight and emitted from this metal plate, that is the energy gained by the electrons from this sunlight and the electrons are emitted from this metal plate, that is the emitter plate. When the electrons are emitted, so these electrons are attracted towards the collector plate because this plate is positively charged, so the electrons are negatively charged, hence these are attracted due to here in the collector plate we have positive charges. Here because we connected the external source, here the battery, that is here we have positive, hence this plate we get the positive charges. So due to positive and negative, the attractive force will between the electrons and to that of the collector plate and hence the flow of electrons. So the electrons will flow in this external circuit. So the flow of electrons we call as electric current. The flow of electrons per unit time, that one we call as electric current. So this flow of electrons in the external circuit, then the ammeter shows the deflection, that is the flow of current here, right? So he observed that, Lensons observed that when a ultraviolet red light falls onto the metal plate, then the current will be flowing the external circuit, right? Later what he did means he stopped the light, that is ultraviolet light or ultraviolet radiation is stopped to falls on this metal plate. Then what happens, he observed that there will be no flow of current, right? So when he stopped the ultraviolet light which falls onto this emitter plate, he observed that there will be no flow of current in the external circuit. So he concluded that when the UV light falls onto this metal surface, then the electrons are emitted from that metal surface and the current will flow in the external circuit. So the Lensons observation is that when the UV light falls or strikes falls on the emitter plate, or simply we say that on the metal plate, then electrons are emitted from the emitter plate. So this is the conclusion by the Lensons observation. Whenever the UV light falls onto this metal surface, then only the electrons are emitted. So hence it proves that the emission of the photoelectrons, that is photoelectric emission. When the ultraviolet light is stopped to falls on this metal plate, then there will be no flow of the electrons, and hence there will be no current in the external circuit. So this is observed by the Lensons. Right, so this one is the simple experiment. So for that experiment, he taken one evacuated glass tube and he placed two metal plates inside the evacuated glass tube, and he made to fall the ultraviolet light to the emitter plate. Then this emitter plate have electrons, gains the energy from the sunlight, and the electrons are emitted. Here the collector plate collects the electrons and it flows in the external circuit. Right, the electrons are flowing in the external circuit. Hence, the ammeter shows the deflection. Hence, it tells that the current is flowing in the external circuit. So when he stopped the flow of ultraviolet lights, that is, when it stops to falls on this emitter plate, then there will be no electrons are emitted. That is, he observed that when he stopped the ultraviolet lights to falls on the surface, there will be no deflection in the ammeter. Hence, he tells that there will be no electrons are emitted from this surface. Right? So he concluded that when the UV light falls onto the emitter plate, then the electrons are emitted from this emitter plate. So this is the observation by the Lensons. Right, so when UV light falls onto the metal plate, then only ammeter shows the deflection. If the UV light which will not falls onto this emitter plate, then there will be no deflection in this ammeter. So no deflection means there will be no emission of electrons. Right, this is the observation by the Lensons. Right, so next, Hallward's observation. So what he did means, Hallward considered one zinc plate. So this one is the zinc plate. Right. So first he considered one zinc plate. So this zinc plate is negatively charged. That is, it has more number of electrons than the positive ions. That is, electrons is more in number compared to that of the positive. Right? So metal, nothing but it has both electric charges and also the positive, that is negative charges and also positive charges. So what he did means, he taken one zinc plate and it is negatively charged. Later he connected this zinc plate with an electroscope. So he connected this one to the electroscope. So as you already studied in this first chapter, that is gold leaf electroscope. So these are the gold leaves and this one is the electroscope. Right? So in this also negatively charged means in the gold leaf also we have negative charges. So next what he did means, when the ultraviolet light which falls onto this zinc plate. So this one is UV light, that is ultraviolet light. So when the ultraviolet light which falls onto this zinc plate, then the electrons are emitted from this metal surface. That is, here If we observe here, there will be some angle theta between these two leaves, right? So here is the angle theta. He observed in the electroscope when the ultraviolet light falls onto the zinc plate, this degree of divergence, that is angle theta, goes on decreasing. That is, here the number of electrons are decreasing. Then finally it reaches to straight line. That is, here theta is equals to 0. These two are with an angle theta. When the ultraviolet light which falls onto the zinc plate, here the number of the electrons are goes on decreasing. So here the number of electrons are goes on decreasing means this theta value is goes on decreasing. Then finally it becomes straight line like this. So these are the two leaves after incident on the ultraviolet light. So the here angle theta becomes 0. So this means that the electrons or the negatively charged electrons are emitted from this metal surface. That is, from the zinc plate it is initially negatively charged. Right? So this negatively charged zinc plate is connected to the electroscope. Here we have the two leaves. On the two leaves we have the charges. That is, we have the negative charges like this. That is before the incident of the ultraviolet light. So when the ultraviolet light which falls onto this zinc plate, then the number of electrons on this leaves or goes on decreasing. So here the number of electrons goes on decreasing is nothing but the electrons on in this plate are emitting. So after it reaches to the neutral position, so in this zinc plate, this plate becomes negatively charged plate becomes neutral. That is, it becomes neutral plate. That is, the number of positive charges is equals to the number of negative charges. Right? So understand this one. Initially what he did, he considered one zinc plate, that is negatively charged zinc plate. Next, this negatively charged zinc plate is connected to an electroscope. So in the electroscope we have two gold leaves. So on that gold leaves we have the negatively charged electrons. So this gives the number of charges in this electric plate, that is negatively charged zinc plate. Now what happens here, when the ultraviolet light makes to falls on this zinc plate, then here the number of electrons on this gold leaves are goes on decreasing. As the number of electrons goes on decreasing means these gold leaves are approaching to each other. So here they have divergence with an angle, right, like this. As the electrons are goes on decreasing, then two gold leaves are approaches to each other. So this shows that the electrons are emitting from this zinc plate. So he observed that the electrons are emitting from this zinc plate, and finally all the negatively charged electrons are emitted from this zinc plate. Then this plate becomes neutral plate, right? Further, he made to incident the ultraviolet light on this zinc plate, so all the electrons are emitted, and finally this zinc plate is becomes only positive charge. Only positive charges will be present on this zinc plate. Positive charged zinc plate, right? So he observed first the negatively charged electrons are emitted from this zinc plate. He further incident the ultraviolet light to this zinc plate. Then the electrons which are present in the neutral state, those electrons are also emitted from this surface. Then the zinc plate will have only the positive charges like this. That is positively charged zinc plate. So initially it is negatively charged zinc plate. Initially we have taken this plate as negatively charged. After the incident of the ultraviolet light, this negatively charged zinc plate becomes positively charged zinc plate. So this can be observed through the electroscope. So this is the observation by the Howard. So observation of Howard is also similar to that of the observation made by the lens, but here the experimental setup is different. So here also it says that an ultraviolet light which falls onto the zinc plate, the negative charged zinc plate, the electrons are emitted and it comes to the neutral. After further incident on the ultraviolet light, then the more number of electrons are emitted from this zinc plate, and finally the zinc plate becomes positively charged zinc plate. So this one is the observation did by the Howards, right? Further, the Howards and Lensons combinedly observed that, so these two scientists are togetherly observed that observed that if any metal surface is there, when the light which incident on this metal surface, there will be no emission of electrons from the metal surface. So both Lensons and Howard observed that for certain metals, when a light incident, that is UV light, which incident on this metal surface, then also there will be no emission of the electrons, right? So by this they conclude that for the wavelength or frequency which falls onto this metal plate should be have minimum frequency to emit the electrons from this metal surface. So that frequency we call as threshold frequency. So the light have the frequency needed to emit the electrons from this metal surface. So the light should have this frequency. So minimum frequency needed to emit the electrons from this metal surface. So that frequency we call as threshold frequency, right? So Howard and Lensons observed that for a certain metals, when a light of ultraviolet which falls onto the metals, then there will be no emission of electrons from that metal surface. So by this they find that these wavelength, that is the light which falls onto the metal surface, should have minimum frequency to emit the electrons. So that frequency is called as threshold frequency, right? So this is the observation did by the Howard and Lensons, right? For some metals, like zinc, cadmium, magnesium, etc. For all these metals, the UV light, when the UV light which falls, that is of shorter wavelength, is responsible for the emission of the electrons from this metal surface. So Lensons and Hallwards observed that for some metals like zinc, cadmium and magnesium etc., for these metals the UV light having the shorter wavelength is responsible for the emission of the electrons, right? So he observed for some metals, for some alkali metals, so they found that for some alkali metals such as sodium, potassium, rubidium. So for this type of metals, that is for alkali metals, the visible light is responsible for emission of electrons. So here we have two types. So here for few metals such as zinc, cadmium, etc., for those metals the UV light of shorter wavelength is responsible for the emission of electrons. In the similar way, they find for some alkali metals such as sodium, potassium, these are sensible for the visible light. That is, when the visible light, normal light which falls onto these type of materials or substances, then the electrons are emitted from these surfaces. Hence, these substances are called as photosensitive substances. Photosensitive substances, right? Here they observed one kind of metals, that are substances, that is zinc, cadmium. These all emits the electrons for the ultraviolet light, that is of the shorter wavelength, and some metals, that is alkali metals, that is sodium, potassium, rubidium, cesium. So these are all the alkali metals. So these alkali metals are emits the electrons only for the visible light. Not only for the visible light, that is for the visible light also, these are the emits the electrons from these surfaces. Hence these are very sensitive for the sunlight or visible light. We say that these are sensitive for the visible light, hence those substances are called as photosensitive substances. So example for the photosensitive substances are sodium, potassium, cesium, rubidium. All alkali metals are photosensitive substances. So here they concluded that the minimum frequency is required to emit the electrons. So threshold frequency is nothing but the minimum frequency for the emission of the electrons. So for all frequency, so this depends on nature of the metals, right? So the threshold frequency depends on the nature of the metal. For different metals, they have the different threshold frequency. So all the metals does not emit the electrons. For example, here these are the metals which emits the electrons for UV light. So same, these metals will not emit for the visible light. So here the threshold frequency is different for these metals, and here the threshold frequency is different for these metals, that is alkali metals, right? So these are the experimental observation did by the Heinrich, Hertz, Hallwards and Lensons observation. So they set up the three different experimental setup and they find the emission of the photoelectrons, that is photoelectric emission. So in this main, that is threshold frequency, and also here alkali metals. So alkali metals are also called as photosensitive substances because for the visible light they emit the electrons from this metal surface. Right? So in the next class we will discuss the experimental setup and experimental observation. That is how the photocurrent depends on the intensity, frequency and also the potential across between the plates. So and all these will be discussed in our next class. Thank you.